Good evening, everyone. My name is Rahul Das, and I am honored to present alongside my teammates Rishi Puri and Pranjal Kalu. Today, we will delve into the fascinating world of data structure, especially focusing on operations and applications of stack data types. Data stacks are the fundamental component in computer science and play a critical role in various computational processes. At its core, a stack is a collection of elements with two primary operations. Push, which adds an element to the top of the stack, and pop, which removes the topmost element. The last in first out, or or we can also call it as the LIFO methodology, ensures that most recently added element is the first to be removed. The efficiency and simplicity of this structure make it an invaluable tool for managing data flow and algorithms and applications. The defining characteristics of stacks are straightforward yet powerful. The LIFO principle ensures that data is processed in a strict reverse order of its entry, which is particularly useful in scenarios such as function call management, where most recent functions need calling to be addressed first. Furthermore, stack operations are generally time efficient, with both push and pop operations having time complexity. This efficiency is crucial in real-time application where speed and performance are paramount. So we find numerous applications in the real world. One of the most common uses is the implementation of function call and recursion in programming languages. So we will look into that further. So now my teammate Pranjal will elaborate further on this topic.
Good evening, everyone. I'm Pranjal, and I'm here with my teammates Rahul Das and Rishi Puri. And today we are presenting on the fascinating topic of operation on stack and stack abstract data types. Let's start with a quick definition of what a stack is in computer science. A stack is a data structure that operates in a last in first out LIFO manner. This simply means that the most recent item added to the stack is the first to be removed. Stacks play a crucial role in many computing applications, and understanding their operations is essential for grasping their use. The primary operations on a stack are push and pop. Let's take a closer look at each. The push operation is used to add an element to the top of the stack. Imagine a stack of books where each new book is placed on the top of others. Each push add one more item on the top. This operation is efficient and usually has a time complexity of O1 since it doesn't require any additional searches or shifts. The pop operation, on the other hand, removes the top item from the stack, effectively reversing the push. Using our book stack analogy, popping would mean removing the book on top. Pop operations are also open as they are only interact with the last element added. Stacks have real world applications that include managing function calls in programming, implementing undo features in text editors, and backtracking in navigation. Their simple structure combined with the efficiency of push and pop operations makes stack essential for effective data management. In conclusion, stacks and their operations are fundamental to understanding more complex data, structures, and algorithms. Thank you for listening, and my friend Rishi Puri will present next.
तू कब वो प्रेजेंट वो कर
Start.
Hello, good morning everyone, and I am Rishi Puri, joined by my teammates Pranjal Khali and Rahul Das. Today my topic is abstract data type of operation on stacks. To briefly introduce, a stack is a data structure that follows LIFO principle, which is last in first out, which as the name suggests, the last element inserted is the first one to be removed, and the stack are used in widely used in computer application thanks to their straightforward structure and operations. Today I'll be focusing on the two topics or two operations, top and is full and is empty. First one, I'll be discussing about top. The top operation is used to access the item currently at the top of the stack without removing it. The operation is essential because it allows you to check whether the no which allows you to inspect the most recently added element in the stack, whether for the calculation, decision making process, or simply checking the stack content. For example, take a function called management. Knowing the top function will help you to determine what to execute next. The time complexity of top operation is O1, making it very efficient. Next comes is empty and is full. The operation provides critical insight into the stack status, which means like it is empty or it is not empty. We can check if there are any elements left in the stack, returning true if the stack is empty. This is essential to prevent. This is essential for the prevention of error while performing the operation like pop. Because the empty stack, we cannot remove the other elements, like it doesn't have any element, so we cannot remove any element which is not in the stack. Is full, cancel. Now we come to the is full. Is full, on the other hand, checks if the stack is has reached the maximum capacity, which is particularly relevant when we are working with the stack of fixed size, which is when we cannot create the extra space for the elements, and we don't have the flexibility to add other elements that restricts our data. So in this condition, we reach the maximum capacity of the stacks, such as those implemented in arrays. So these three operations helps us in to conclude my topic. We can say that these three processes, is empty, is full, and top, these helps us in checking and getting to know more about the stacks and its processes. Thank you.
So now I would like to discuss some real world application of stack abstract data types and their significance in various fields. Stacks, as in last in first out data structure, have unique advantages that make them essential in numerous applications we rely on daily. One prominent example is in function call management in programming. When a program calls a function, it pushes information onto a call stack about the function parameters. Um, about the function parameter. So when to return once the function finishes, this ensure each function has its own place in memory and can execute independently while allowing the program to run seamlessly to its previous state after each function call completes. Similarly, stacks are used to manage recursive function calls, providing each recursive step with its necessary context. Stacks are also critical in web browsers where they manage page navigation history. Each time a user navigates a new page, the current page is pushed onto the stack, allowing for an intuitive back button feature that leads the user to return to the previous page quickly. Stacks are also instrumental in text editors where the undo feature relies on pushing change onto a stack, allowing users to revert their actions by popping the last change off. In algorithmic applications, stack played a key role in expression evaluation and parsing. For instance, the shunting yard algorithm and the reverse Polish notation are commonly used in calculators, depend on stacks to evaluate mathematical expressions correctly. In compilers, stacks assist in parsing nested expressions and matching parentheses in code syntax, ensuring code structures are followed properly. In conclusion, stacks are fundamental in many systems we interact with daily, from programming and web navigation to text editing and calculations. Their efficiency and simplicity make them a powerful tool, demonstrating that even basic data structure can drive significant functionality across various domains. Thank you for your attention.
माइक बंद है तेरा।